Good morning, children. How are you? I hope you all are fine. Yes, in the previous class itself, we have completed Unit 4. Now we came into Unit 5. Okay. What is the Unit 5? That is motion of system of rigid particles and rigid bodies. Okay. And this is the Unit 5. Okay. Let's see the topics one by one. First of all, what is a rigid body? Okay. So most of the object that we come across in our day-to-day life, okay, that consists of large number of particles, okay. So in the previous units, we studied the motion of bodies without considering the size and shape. So as far we have treated even the bulk bodies as only point objects. So in the section, we will give importance to the size and shape of the bodies. So these bodies are actually made up of large number of particles. Okay. So when such a body moves, we consider it as the motion of collection of particles as a whole. So we define the concept of center of mass to deal with such a system of particles. Okay. The forces acting on these bulk bodies are classified into internal and external forces. Okay. What are internal forces? The internal forces are the forces that is acting among the particles within a system that constitute the body. Okay, what are external forces? External forces are the forces acting on the particles of the system from outside. Okay, so in this unit, we deal with such system of particles which make different rigid bodies. Okay. Okay, that is what is a rigid body. Okay, a rigid body is one which maintains its definite and fixed shape even when an external force act on it. எவ்வளவுதான் external force act ஆனாலும் அதோட shapeல இருந்து அதோட sizeல இருந்து அது மாறாது. That is the rigid body. Okay, what is a rigid body? A rigid body is the one which maintains its definite and fixed shape even when an external force acts on it. This means that the interatomic distances do not change in a rigid body. Okay, so when an external force is applied. So however, in a real life situation, okay, real life situation, we have bodies which are not ideally rigid. Okay, so because the shape and size of the body that change, okay, when forces act on them. So for the rigid bodies we study here, so we assume that such deformations are negligible. So the deformation produced on non-rigid bodies are studied separately in unit 7. Okay, that is elasticity of solids. Okay, we will see it later. Okay, that is the rigid body. Okay. Now, what is center of mass? Okay, center of mass. Okay, so when a rigid body moves, okay, or a rigid body that is moving, all the particles that constitute the body need not take the same path. Okay, so depending on the type of motion, different particles of the body may take different paths. Okay, so for example, when a wheel rolls on a surface, the path of the center point of the wheel and the paths of the other points of the wheel are different. So in this unit, we study about the translation, rotation and the combination of these motions of rigid bodies. Okay. So for bodies of regular shape and uniform mass distribution, center of mass is the geometric center of the body. Center of mass is the geometric center. Okay. The center of mass enna appadina perfect point of reference nu sollalam. That is used to calculate the net moment for an unconstrained rigid body. Okay. Unconstrained rigid body. Okay, the center of mass could be well within the body and in some cases outside the body as well as. Okay, this is the center of mass. Now the center of mass for distributed masses. Okay, so a point mass. Okay, so when a bulk object, okay, or bat எடுத்துக்கிறோம், okay, that is thrown at an angle in air. Airல அந்த bat நம்ம throw பண்றோம். Okay, all the points of the body take a parabolic path. Okay, do all the எல்லா பேட்டுமே parabolic pathல இருக்குமா? No, actually only one point takes the parabolic path and other points takes the different path. Okay, so the one point that takes the parabolic path is very special point. That is called the center of mass. That is called the center of mass of the body. Okay, so its motion is like the motion of a single point that is thrown. So the center of mass of a body is defined as a point where the entire mass of the body appears to be concentrated. So therefore this point can represent the entire body. Okay, that is okay, that is the center of mass of the body. Okay, so what is it for distribute single okay, distributed point masses so a point mass, that is a hypothetical point particle which has non-zero mass and no size or shape. So to find the center of mass for a collection of point masses, that is M1, M2, M3 like that. So we have to first choose an origin and an appropriate coordinate system. See the picture, we are taking a coordinate system, that is x1, x2, x3 up to xn be the x coordinates of the positions of these point masses in the x direction from the origin. Okay, right? You understood? So we will get the equation, okay, that is x equal to summation of m1 x1 by summation of m, where summation of m is the total mass m of all the particles. Okay, finally we will get RCM, okay, that is the distribution point masses equal to summation of MIRI by M. Okay, do you understood? Now, what is the center of mass of 2 point masses? Center of mass of 2 point masses. Okay, so with the equations for center of mass, let us find the center of mass of 2 point masses M1 and M2, which are at positions x1 and x2 respectively on the x-axis. So for this case, we can express the position of center of mass in the following 3 ways, that is based on the choice of the coordinate system. Okay, first of all, there are 3 cases. In the first case, when the masses are on the positive x-axis. Second case, when the origin coincides with any of the masses. Third case, when the origin coincides with the center of mass itself. So, first of all, when the masses are on the positive x-axis, what happens? That xcm equal to cm na center of mass. Okay, that is m1 x1 plus m2 x2 by m1 plus m2. இதுதான் positive x-axis. இதுவே coincide ஆகுது, ஏதாவது ஒரு சைடுல தான் coincide ஆகுதுன்னா m1 into 0. ஓகேவா, அந்த x1 வேல்யூ 0 போட்டுட்டு பண்ணிக்கணும், அவ்வளவுதான். ஓகேவா, அப்ப என்ன ஆகும் ஈக்குவேஷன்? m2 x2. ஓகேவா, m2 x2 divided by m1 plus m2. அதுவே third equation எடுத்துக்கிட்டோம் அப்படின்னா அந்த x1 வேல்யூ மைனஸ்னு போட்டுட்டு x வேல்யூ ஈக்குவல் டு 0 போட போறோம். அப்படின்னா ஃபைனலா என்ன கிடைக்க போகுது? m1 x1 equal to m2 x2. இதுதான் when the origin coincide with the center of mass itself. Okay. Next, center of mass for uniform distribution of mass. So, if the mass is uniformly distributed in a bulk object, okay, so then a small mass of the body can be treated as a point mass, and the summations can be done to obtain the expressions for the coordinates of center of mass. Okay, so on the other hand, okay, if the small mass is taken infinitesimally, then the summations can be replaced by integrations. Okay, see that integrations are given. Xcm equal to summation of, so integration of x dm by dm. Okay, like that. These are the distribution of masses. Okay. Now, motion of center of mass. Motion of center of mass. Okay. So, when a rigid body moves, okay, its center of mass will also move along with the body. So, for kinematic quantities like velocity and acceleration of the center of mass, we can differentiate the expression for position of center of mass with respect to time once and twice respectively. Okay. For simplicity, let us take the motion along x direction only. Okay. So, in the absence of external force, the individual rigid bodies of a system can move or shift only due to the internal forces. Okay. So, this will not affect the position of the center of mass. So, this means that the center of mass will be in a state of rest or of uniform motion. Okay. Do you understood? So here, the individual particles may still move with their respective velocities and accelerations due to internal forces. So in the presence of external force, the center of mass of the system will accelerate, okay, as given in the equation. Now, what is torque and angular momentum? Okay, torque and angular momentum. So when a net force acts on a body, okay, or body irukku anga or net force act agudhu, it produces a linear motion. It produces a linear motion in the direction of the applied force. Okay, so if the body is fixed, okay, body is fixed to a point or an axis, so such a force rotates the body. Okay, it rotates the body depending on the point of application of the force on the body. Okay, so this ability of the force to produce rotational motion, okay, ability of the force to produce the rotational motion, that is called the torque or the moment of force. So examples for such are happening in our day-to-day life. Okay, so the opening and closing of the door, okay, opening and closing of the door, that hinges and turning of the nut using a wrench. Okay, so the extent of the rotation depends on the magnitude of the force, so its direction and the distance between the fixed point and the point of application. So when torque produces rotational motion in a body, its angular momentum changes with respect to time. So in this section, we will learn about the torque and its effect on rigid bodies. Okay, understood? Now, what is a torque? Torque is defined as it is a moment of the external applied force, okay, about a point or an axis of rotation. That expression is tau, okay, and the symbol on the torque or symbol on the tau nu solluvom. Tau equal to, okay, that is R into F, where R is the position vector, where F is the force. Okay, so R position vector, F on the force. Okay, so torque is the quantity that measures the ability of the force to rotate an object around some axis. So lever arm is the perpendicular distance from the axis of rotation to a line drawn along the direction of the force. So this torque depends on force and length of the lever arm. So torque is equal to force into lever arm. Force into lever arm. This is the definition for torque. So here the product of R and F is called the vector product or the cross product. Vector or cross product. Okay, so the vector product of two vectors that results in another vector. So that is perpendicular to both the vectors. So torque has a magnitude and direction that is perpendicular to R vector and F vector. Its unit is represented by Nm, Newton meter. So tau equal to R into F if represented in theta, that is sin theta. So theta is the angle between R and F. And n cap is the unit vector in the direction of tau. So torque is sometimes called as pseudo vector as it needs the other two vectors R vector and F vector for its existence. Okay, so the direction of torque is found using the right hand rule. Okay, so this rule says that if fingers of the right hand are kept along the position vector with palm that is facing the direction of the force and fingers are curled. Okay, see your book page number 218. Okay, 218. You will be see. Okay, you will be see the direction of torque that helps to find the type of rotation that is caused by the torque. For example, if the direction of torque is out of the paper, then the rotation produced by the torque is anti-clockwise. Okay, so on the other hand, if the direction of the torque is into the paper, then the rotation is clockwise. Okay, do you understood, children? Right, now what is torque and angular momentum? So in the earlier sections, okay, we have dealt with the torque about a point. So in this section, we are going to deal the torque about an axis. Okay, torque about an axis is also dealt. Okay, what is torque about an axis? That will rotate the object about it, and the torque perpendicular to the axis will turn the axis of rotation. So when both exist simultaneously on a rigid body, the body will have a precession. So one can witness the precessional motion in spinning top when it is about to come to rest. Okay, so study of precession is beyond the scope of the higher secondary physics course. So hence it is assumed that there are constraints to cancel the effect of perpendicular components of the torques so that the fixed position of the axis is maintained. So therefore perpendicular components of the torque need not be taken into account. Okay, so now what is torque and acceleration? Let us consider a rigid body. Okay, let us consider a rigid body that is rotated in a fixed axis. See the picture, that is rotating in a fixed axis. There is a point mass, okay, in the body wall that is executing a circular motion about the fixed axis. Okay, now the tangential force F that is acting on the point mass, it produces a necessary torque for this rotation. So this force is perpendicular to the position vector. Position vector is what? R. So this force is perpendicular to the position vector. Okay, that is 90 degree. Okay, do you understand? So F equal to ma. So the angular equivalent would be tau equal to I alpha. Tau equal to I alpha. So how it comes? Tau equal to R into F. We see the formula for torque, no? R into F. Next, if we denote it in theta value, RF sin theta. RF sin theta. Now tau equal to RF equal to F க்கு பதிலா MA. So R, what happens? RMRA. That is I alpha. I alpha. Because I is moment of inertia. Alpha is the acceleration. So I is what? Moment of inertia. Moment of inertia என்னது mr. mr square. அப்போ mr square எப்படி எழுதலாம்? r mr னு இருக்கு. r mr னா mr square னு போட்டுக்கலாமா? அப்போ mr square னா என்னது? Moment of inertia, அது வந்து I. அப்போ I alpha. alphaங்கிறது acceleration. So நமக்கு என்ன தெரியுது அப்படின்னா term m square is called the moment of inertia. So a rigid body that is made up of many such point masses. Hence the moment of inertia of a rigid body is the sum of moments of the inertia of all individual points. Okay. Now, what is angular momentum? So, the angular momentum in rotational motion is equivalent to linear momentum in translation motion. So, the angular momentum of a point mass is defined as the moment of its linear momentum. So, in other words, the angular momentum of a point mass that is having a linear momentum at a position R with respect to a point or axis, that is written as L equal to R into P. So, an object that is small compared to the radial distance of the axis of rotation. So, angular momentum எப்படி எழுதுவாங்க? mvr. So, in terms of theta, we are writing the magnitude of angular momentum L equal to rp sin theta, where theta is the angle between R and P. So, L is the perpendicular to the plane that is containing R and P. So, as we have written in the case of torque, here also we can associate sin theta with either R or P, where P perpendicular, okay, is the component of linear momentum. P is perpendicular to R, okay. So, there is a misconception that the angular momentum is a quantity that is associated only with rotational motion. So, it is not true. So, the angular momentum is also associated with bodies in the linear motion. So, let us understand the same following with an example, okay, right? Newton's first law of inertia for rotating objects in terms of. Next, equilibrium of rigid bodies. Equilibrium of rigid bodies. So, when a body is at rest, okay, when a body is at rest without any motion on a table, or a table la or a body irukku without any motion. So, we can say that there is no force acting on the body. So, actually it is wrong because there is a gravitational force acting on the body. அப்படிதானே? ஒரு டேபிள் ஒரு புக் இருக்கு, ஒரு ஆப்ஜெக்ட் இருக்குன்னா அது அசையாம இருக்கிறதுனால அதுல ஒரு ஃபோர்ஸுமே ஆக்ட் ஆகலன்னு சொல்ல முடியாது. பட் தேர் இஸ் a gravitational force. Gravitational force இருக்கிறதுனாலதான் அந்த டேபிள்ல உட்கார்ந்துருக்கீங்க அப்படின்னா அது பறந்துகிட்டு இருக்கும். ஓகேவா? So gravitational force that is acting on the body downward, and also the normal force exerted by table on the body upward. So these two forces cancel each other. So thus there is no net force acting on the body. There is a lot of difference between the terms no force and no net force acting on a body. The same argument holds good for rotational conditions in terms of torque or moment of force. Okay, a rigid body is said to be in mechanical equilibrium when both its linear momentum and angular momentum remains constant. Okay, do you understand? Right. So if the forces F1, F2, F3 are acting in the same directions, okay, we can resolve into horizontal and vertical components. Horizontal and vertical components, okay. So there are two conditions for equilibrium. The net force வந்து 0, that is translational equilibrium, அல்லது net torque equal to 0, அது வந்து rotational equilibrium. See the picture when two children balance on a seesaw, okay. So the heaviest child must be closer to the pivot, okay. The fact, this is the equilibrium. So there are different types of okay, see the types of equilibrium. First of all, translational equilibrium, rotational equilibrium, static equilibrium, dynamic equilibrium, stable equilibrium, unstable equilibrium, neutral equilibrium. Okay, there are several types of equilibriums. Okay, several types of equilibrium. First of all, what is translational? Translationல என்ன அப்படின்னா linear momentum constant இருக்குது, net force வந்து 0. Rotationalல net torque வந்து 0, angular momentum constant இருக்கு. Static equilibrium எடுத்துட்டோம்னா net force net torque ரெண்டுமே 0, linear momentum and angular momentum ரெண்டுமே 0. Okay, dynamic equilibrium எடுத்துட்டோம்னா linear momentum and angular momentum are constant. Net force and net torque are 0. Next is stable equilibrium. Stable equilibrium எடுத்துட்டோம்னா linear momentum and angular momentum are 0. So the body tries to come back to the equilibrium if slightly disturbed and released. So the center of mass of the body slips slightly higher if they distributed from the equilibrium. Next, unstable equilibrium na enna? Linear momentum and angular momentum aga 0 இருக்கும். The body cannot come back to the equilibrium. Lighter disturb அல்லது lighter release ஆனாலும் அதால திரும்ப வர முடியாது. ஓகேவா? Center of mass of the body வந்து slightly lower. Next, neutral equilibrium. So linear momentum and angular momentum are 0. Okay, the center of mass of the body does not shift higher or lower if distributed from the equilibrium. Okay, you understood? Now, what is couple? Okay. What is a couple? Okay. Couple, what is a couple? A pair of forces which are equal in magnitude but opposite in direction, that are separated by a perpendicular distance, and that their lines of action do not coincide, that causes a turning effect, that is called the couple. Okay va? Couple அப்படிங்கிறது ஒரு pair of forces. See the picture. Pair of forces. F அப்படின்னு ரெண்டு forces இருக்கு. Having the same magnitude. ரெண்டுக்குமே ஒரே magnitude தான். 5 Newton 5 Newton, 6 Newton 6 Newton. But அதோட direction எப்படி இருக்கு? Opposite direction. ரெண்டுக்குமே same, but having the different line of action. Okay, opposite direction and different line of action. The pair of forces which are equal in magnitude but opposite in direction and are separated by a perpendicular distance, so that their lines of action do not coincide, that causes a turning effect, that is called a couple. Okay. Understood? So consider a thin uniform rod, that is AB. Its center mass is at the midpoint C. Okay, in the midpoint வந்து D ன்னு எடுத்திருக்காங்க. The two forces are equal in magnitude and opposite in direction are applied at the two ends. Now, A and B of the rod are perpendicular to it. Now, the two forces are separated by a distance 2r. So, as the two equal forces are opposite in direction, they cancel each other, and the net force acting on the rod is 0. Now, the rod is in translational equilibrium, but the rod is not in rotational equilibrium. So, let us see how it is not in rotational equilibrium. The moment of force applied at the end A taken with respect to the center point C, it produces an anti-clockwise rotation. Okay, it produces an anti-clockwise rotation. Now, what are principle of moments? Okay, principle of moments. If the anti-clockwise moment and clockwise moment are equal, then the seesaw is balanced, isn't it? That is the principle of moment. Okay, total clockwise moment equal to total anti-clockwise moment. This is the principle of moments. Okay, principle of moments. What is the center of gravity? Center of gravity of a body, okay, is a point at which entire weight of the body acts irrespective of the position and orientation of the body. Okay, it is an imaginary balancing point where the body weight can be assumed to be concentrated and equally distributed. Okay, it is the point of exact center around which the body may rotate freely in all directions. So it can also be called the center of mass. Okay. Now, bending of a cyclist. Okay, so let us consider a cyclist. Okay, let us consider a cyclist. He is negotiating a circular level road, okay, of radius r with the speed v. The cycle and the cyclist are considered as one system with mass m. Okay. Now, while negotiating the circular level road, radius on the r, velocity v, now the cyclist has to bend at an angle theta. And the theta equal to tan inverse of v square by rg. So, tan inverse of v square by rg. V ingradu velocity, r ingradu radius, g ingradu acceleration due to gravity. Okay, you understood? So, this is the bending of a cyclist. This is the bending of the cyclist. Okay, have you understood? What is center of gravity? So we can also determine the center of gravity of a uniform lamina even at a irregular shape. Okay, so the lamina remains horizontal when pivoted at the point where the net gravitational force acts, which is the center of gravity. Okay, which is the center of gravity. Okay, do you understood? Right? Okay, that's all about today's class. In next class, we can see about moment of inertia and the rest of the lessons. Okay, okay. Your homework is one words. Okay, all the book back short answers is your homework. Study well and write it as an assignment. One words you write in homework note. Short answer questions mattu na. Okay, wa? Short answers questions. Okay, you go through the book or you may having guide. Okay, short answers questions nalla study panni book back ella questions ayum assignment la proper படிச்சு எழுதுங்க. Okay வா? God is seeing you. ஓகே, மனசாட்சிக்கு புரிஞ்சு நல்லா படிச்சு பாராம எழுதி பாருங்க. அண்ட் ஒரு டைம் சப்மிட் பண்ண சொல்லுவோம். அப்போ செக்கிங் வில் பி தேர் அண்ட் மார்க்ஸ் வில் பி கிவன். அது உங்களுக்கு தெரியாது, பட் குவார்டர்லி எக்ஸாம் இதெல்லாம் உங்களுக்கு நடக்காததுனால இந்த மார்க்ஸ் எல்லாம் இருக்கும். யூ ஆர் ஹேவிங் டெஸ்ட் ஆல்சோ ரெகுலர்லி. So don't waste a single time. Study well. Okay children, have a nice day. Thank you.